ladies and gentlemen. Today we are going to be fine-tuning Llama 3 on ChatGPT chat history. That is going to consist of downloading the ChatGPT history, easy money, formatting the ChatGPT data, sort of easy money, converting it into a Hugging Face dataset, also sort of easy money, and setting up the pipeline to fine-tune Llama 3. And we're also going to be using weights and biases so we can see and process the information as it goes on. This video is just going to show you how to put things together. Code will be in the description with other links and additional information. I definitely recommend heading to my GitHub, checking out the code along with the video and following along. This is going to run locally, but I will also post the Kaggle notebook that I put together. Unfortunately, you're not going to be able to complete this with the free GPU options available. The model's just a little bit too big, a little frustrating, but that's how it is. So let's get to it right away. All right, so here's a slideshow for some reason, just to, compose our thought. We want to make bad models better, and a bad model is just a model that isn't doing what we want, not properly aligned. There's basically three options here. We can modify the model weights, modify the model inputs, or we can modify the model's feature. And when I say features, I don't mean weights and parameters. I mean features as in the package that the model is wrapped up in code-wise. We can modify the thing, that we can modify the program, irrespective of the components of the model. So modifying the model features, we got, RAG is pretty popular. That's just retrieval, but it's a special method of retrieval, or at least it can be, that's affect tool usage and external knowledge bases. All of these, including RAG, come down to providing additional things to the model that it's not trained on, but it can use as a human would through reasoning. Tools, very popular. That's what we're using with LangChain. That's what we're trying to get going. Being able to interrupt the generation, refer to something else, and continue the generation. External knowledge bases, that's similar to RAG in that we're taking external information and we are using that to bolster the generation with respect to the input. Prompt engineering, this is another method of modifying the outputs. So just giving a different prompt. Prompt engineering, I'm not sure if this spy counts under that, but there's a lot of methods to modify the inputs, and I'm going to call all of those prompt engineering. Not necessarily just prompting, but anything that is not modifying code and is not training, I'm going to call prompt engineering. Anything that's at runtime. But the two most popular things are prompt tuning and few shot learning. Prompt tuning is, what most people would consider prompt engineering, just using a different prompt. And few shot learning is just providing additional examples. Tree of thoughts, graph of thoughts, these kinds of things are kind of advanced few shot learning techniques. So there's a few of those. This is the best. Ideally, if you can get the performance you want to use some form of runtime modification. It's less computationally expensive and it uses less resources. This is the ideal, but it's not always possible. And modifying the model weights. This is training. This is the most computationally expensive option, but in theory, it is the best way to align the model. Essentially, this is going to be like few shot learning, except not few shot, a whole lot of shot, many shot, super shot. Not only many shot learning, but persistently modifying the model so that it remembers what you taught it. We're going to be doing fine tuning. Fine tuning is, it's just training. There's no real difference here, except in our case, we're going to be fine tuning a separate set of weights called the adapter. And we're going to add the adapter weights to the original weights to give us new weights that are more in line. And we're also going to be modifying the matrices that compose the model, and we are going to reduce the ranking of those. I'm not going to really go into that because there's about 300 videos on fine-tuning and LoRa on YouTube that I suggest you check out. The value of this video is all the code put together in a single space that you can actually just download and run. All right, so we'll be looking at three files today. There's the ChatGPT history to training. This is what you're going to use after you extract the ChatGPT chat history from ChatGPT. They're going to send you an email with the zip. We'll do that in a second. Then there's the Llama 3 fine-tuned file. This is just using transformers and Hugging Face Hub to take the data that's been properly formatted from the ChatGPT history to training file and put it through the training pipeline, train the adapter model, and get you set up to begin the merging process. Then there's the merge adapter to base file. This is going to take the adapted model that's using LoRa and I think 4-bit quantization with bits and bytes, and it's going to merge the adapter author and the base model together to give you a new model. You then can push this model to the Hugging Face hub. I should have changed these names, and you should as well, to be whatever you want. Then after that, we can convert it to a .cpp and then go to a gguf so that we can use it locally on some of the more popular local inference GUIs. Okay, so for the sources, the best source was this radar, which is going to give you a guide to fine-tuning Llama 3. They're using a chat doctor dataset. Then there's the LLAMA3, or however the hell you say that. They're doing ORPO. There's a few that are using the ORPO dataset. Then there's this guide on fine-tuning Mistral 7B. This is also pretty good. All of these are pretty good at setting you up with the SFT trainer and getting your SFTT trainer, SFT trainer, your training arguments and all this stuff, this kind of thing here, setting up the model and getting you ready with weights and biases. They're all pretty much identical, and the code for that is, you could probably get GPT to make that for you if you just pass in the URL to this and have it look at it. Creating the data set, for some reason there's not a template for that. So all there is that I could find was just the documentation from Hugging Face. So that's fine, but you have to specify a formatting function, which is very easy. Just finding the format, getting the format from the data was a little bit annoying because the GPT data comes as just the way that it comes is kind of ugly, and we'll take a look at that. All right, so the data comes as this giant list of title and information kind of pairs here. Here's a piece of one section of that. So you get the title of the chat, create time, update time, some mapping information, maybe some other stuff here, and then you get the portion here with the author and the content. And the author is going to give you the role, the name, and some metadata. We're interested in the role. It's a user or assistant for ChatGPT, and the content is the message. And that is basically what we're extracting. This portion here, just the author and the content. All right, so let's get that history. It's super simple to get the ChatGPT history. Just log into your account, go to setting, go to data controls, and then export data. And when you export the data, it's going to send you an email. It's not going to take more than a day. It took me about 15 minutes to get the email. When you get the email, you're going to get a zip file that you want to extract, and it's going to give you these 6 files. The conversations.json is what you want, and the chat.html is going to show you the chat in kind of a nice HTML format. What you have here is all of the chats, and there's a ton of them. So I think it's easiest to do the formatting, save all the chats somewhere else, and then have a separate function that extracts the specific chats that you want. Or you can it's a data frame, so you can get a list of all of the chats. It's a column, and then you can pass that whole list in, and it'll extract all the chats. So both of those will work, and we'll show that in a second. Okay, so now that you have your data from OpenAI emailed and unzipped, you're only going to need the conversation.json file from here. There's a few functions that extract data from the conversations.json file, put them into data frames or other formats. The two that we're going to stick with in this example are the create dataset prompt and response and the export selected chats to CSV. This is going to create the data frame, and I recommend using this in Spider or using this in a notebook so that you can have persistence of the variables between runs. And once you have this data frame, you can do whatever you normally do with a data frame. But if you want to create a file, I have this that converts the data frame into a CSV, but ideally you also would want to save the data frame and then save it to file as a parquet. So you have the CSV and the parquet. The CSV saves everything as a string, so parsing through that gets a little bit annoying, but it is easier to pass around and just have and look at and examine as an object. The parquet is what you're going to want to save as if you're passing this or uploading this anywhere. This is what the model itself is going to work with. Okay, and again, this isn't supposed to be a comprehensive video, just showing you that the code exists and how to run it and get you started. We'll do some more in-depth stuff, and if you have any questions, just email me. Next, I'm going to show you on Kaggle, my initial attempt. Kaggle, unfortunately, was not able to store the entire model, especially not both the model and the adapter at the same time. So I did end up having to move from Kaggle. I'm not going to upload the Kaggle notebook, most likely because uploading notebooks is kind of annoying since it doesn't automatically update the notebook in GitHub. So there's too many changes that I'll be doing. So the upcoming video is just going to go over exactly what we're running when we are fine-tuning the adapter with LoRa and 8-bit quantization. All right, so we're going to use Kaggle. I think they're going to give us some free stuff. It's similar to Colab, except it looks nicer. It's less intimidating. So if we open up a new notebook, to add the model, we're going to go ahead to add input, and we're going to click models. LLAMA3, you have to ask for permission, but if you've already got permission on Hugging Face, it seems to hook you up pretty quick. So go ahead and click that. We're going to use transformers. Reason we're going to use transformers is because it's also integrated with LangChain. So if we're lucky, we'll be able to quickly move things over. And then you want to click down here to the add model, and that's going to get us set up with the model. All right, and then session options. I don't have access to a GPU, but it looks like no cost if we get phone verified. So I'm going to go ahead and enter my phone number, and we'll see how long it takes to get that GPU access. All right, the phone verification, they just sent a text message. It took 2 seconds. I had another account, so I had to delete it. So we have some options here for the GPU. Two T4s should be the same as a P100. I have a P100 locally. It sucks. The 3060 is better. But let's just go with the P100 just to use more power. I have 30 hours, so Kaggle's already better. Okay, and persistence. Let's just keep persistence. Let's do variables and files. So it'll be like Colab would be persistence for variables. So each cell, you can declare a variable, define a variable, instantiate a variable in a cell below another cell, and so we'll keep that. All right, and then this might be the best feature of them all. We have the add-ons here, and then secrets, and then you can enter in all the keys. I'm already very psyched about Kaggle, so we'll go ahead and do that. I'll add all the keys. You're gonna really want your Hugging Face token key, and you might as well put the OpenAI and the Mistral if you're using that. So put your keys in here, and you're good to go. Okay, then start the session. You can see that here's some of the safe tensors. That's the LLAMA3. So it looks like it's local on here. Anyway, so here are the imports that we want to install that aren't included. Transformers, datasets, accelerate, puff, TRL, bits and bytes, and WAN. But hopefully we're not going to need weights and biases. Weights and biases is pretty sick as a feature though, so I do recommend that. So we'll let that run. Okay, so we've pipped installed, we've imported. I'm going to put this in the description, and I'll put the link for the source as well. So we have some options here for the GPU. Two T4s should be about the same, except we're going to make a couple modifications just so that we can use it for other things. We're good to go there. I have a P100 locally. It sucks. All right, so I actually haven't used my weights and biases. I guess I still can use it. I thought I ran out of credits. It looks like they changed it up. It's been a while. So I'm gonna go ahead and add that, and we can use it, and you can see why weights and biases is pretty awesome. Last time I checked, it was something like $100 a month, so I didn't stick with it, but I did like it when I had it. So we'll go ahead and add that. Okay, then we just set up the model. The base model, this is coming from Hugging Face because we're using transformers. So this is the path. The dataset name also from Hugging Face. The base model is on Kaggle, but this is the path. This is once you add the input, this is already set up for you, so you don't have to worry about that. The dataset name, this is from Hugging Face. So when you go to the Hugging Face, so let's just open that up. So you go, here's a dataset, doesn't matter. And then using the datasets library, and it'll give you a link here. Load dataset, that's the link. That's where that comes from. This is a AI medical chatbot dataset, which we're just using as a demo. We're gonna do a custom one. Problem with the custom one, there's no problem. I don't know which format I'm gonna use, but the code is there, so it exists. We're gonna use that. And the new model, you can name this whatever you want. This is just what the trained model, this is your model. TRL, bits and bytes, and WAN. But then the data type, we're going to use float 16-bit precision. You can go to 4. They have 1 bit now. So you have a lot of flexibility here. The attention implementation, we're going to use eager. This is for real coders only. But this is basically how communication goes on between the data on the GPU and the CPU. Okay, so we don't want to train all of the parameters on the model. So this is the PEFT, just a little bit of extra sauce that they put on there that allows us to, here's what it says, enable efficient adaptation of large pre-trained models to various downstream applications by only fine-tuning a small number of extra model parameters instead of all the model parameters. So it's like model distilling on itself for a specific task. You don't really have to worry about that, and I wouldn't change any of these. But this is just basically just hyperparameters for training. But we want to keep everything in Hugging Face, and that's what we're doing here. We're loading this Hugging Face data set, and then we're going to split it with the train test split. We're going to keep 10% for testing, and they're 90% for training. All right, now we're just getting out of the woods. So we've set up the fine tuning. Once we set up the fine tuning, then we want to evaluate the model, and then we want to save the training model setup, and then we're going to have to merge it with LLAMA3. So this is a long process, and then we still haven't set up the data set. So this is not, you're gonna have to buckle in. Grab a cup of coffee. We set up the model hyperparameters so it can run on Kaggle here. It's just basic stuff. One epoch, common for these large language models, because one epoch is a huge amount of data. It's all the data once, and usually it's the entire internet or something. So that's it. I'm gonna go ahead and run this. It's going to take forever, and I'll when it is done. All right, so it's going to give you some links. It looks like I've exceeded 100% of my tracking hours. We're still going to run this and see what happens. Maybe it doesn't know that, but you don't need weights and biases. You're just not going to be able to see, some cool, pretty graphs that you can make yourself from the results output anyway. It's just nice and it's automatic and it does it all for you, but it's not required. Okay, so I've exceeded 100% of my tracking hours. I don't think I have a card link. We've only had one stop of evaluation collection. It's going. And this is weights and biases. As you can see, there's a lot of information. Most of it's pretty much useless. With audio, it's awesome because it'll give you a sample of the audio that you can listen to right there. But yeah, it's running. Okay, I have no payment method on file here and it's still going. It has stopped me before. That's why I stopped using it. I'm not sure why it's not stopping me here, but it is running. Everything looks fine. So once this runs, we'll, then we'll have issues. All right, so we're done. No, with the training. All right, so we still have to evaluate and then we still have to do step 2. You can see validation loss. That's pretty much what we care about. Has decreased. Training loss has also been on a downward trend, but it looks good that the validation loss comparable, if not less, than the training loss as an average. So you can see here, it's working. It's working. I'm sure if we did more epochs, we'd get better results, and we can always do that. So that is the process for that. Let's go ahead and do some evaluation and see how things are going. There we go. Look at that. That's really nice. This setup here is really nice to look at. That's what the weights and biases is going to give you. And it's still letting me run for free, so I would use it. Then here we can go. Let's try and get a generation, and hopefully this will. There we go. That is that better than what ChatGPT would have given us for 8 billion parameters? That's insane. This response is very good. It gave a link. Let's see if the link is real. And I mean, wow. I mean, this is fantastic. This is a really good result. Very happy to see that. Let's just see what this is. GPT 4.0. Yeah, I mean, here we go. It's not giving us sources. It might, but I bet the links don't work. That's a better response than GPT 4.0 with fine tuning. So we'll try and get a custom data set. Next, we'll merge the adapter with the base model so that we can use this. All right, so we are off Kaggle. It was giving us trouble. It's taking too long. It's too slow. They do give free GPUs, so that's nice. So we're going to do this locally. For this specifically, so the adapter plus the model have to both be loaded into VRAM at some point. So 16 gigabytes is not quite enough. There's a couple issues that generally occur with the from pre-trained device map auto. Crazy behavior. No one seems to be able to pinpoint a solution onto why it works sometimes and it doesn't work other times. It doesn't seem to want to appropriately map data between your resources in a logical manner. So the easiest thing to do is set max memory and specify how much you want each device to be responsible for. The 0 GPU, in this case, we're using the CUDA mapping numbers for GPUs. So it's going to go from most powerful to least powerful. So 0 is the 3090, 1 is the 3060, and 2 is the 960. The 960, the 3060, and the 3090 are all each architecturally different, but the 3090 and 3060 are both in the same series. So in this case, we can use them together. When we're doing parallel GPU stuff outside of this, they probably don't work together, and I do have trouble with that. Anyway, this will work here. So this code basically just going to do the PEFT here, which is automatic. Didn't know that. So this is actually one line of code, not very hard, very easy. And that's going to merge the base model and the adapted weights that we just got from the stuff we were doing on Kaggle. All right, so just to summarize, we'll do a separate video on the ChatGPT history. That is working. It's all on the GitHub, so if you want that, you can. All right, so that is going to be part 1. We'll do a part 2 where I actually run through the pipeline. This video is getting a little too long and it takes too long to render. But if you have any questions, obviously ask me, email me, comment, whatever you got. I will respond. I think this is pretty effective and it works really well. It's pretty similar to Alpaca and how they generated training data, instruction training data, and then with another GPT model and passed it through. Here, you're just going off of your chat history with effective chats. And I'll show proper ways to start prompting the model so that in the future you have a nice hefty data set that's actually effective. And this works pretty well. I don't know if this is, it works. So that's what matters. So stay tuned. We'll be here. Peace.